So friends, well, I can now safely say that I've had a hand in the manufacturing of the leaf spring for the Nova 2 Airship. Hello everyone, you're back with the next generation airship project. We're keeping you updated, and today we've come to Polimex, which is the contractor we've hired to manufacture a part of the leaf spring for our Nova 2 Airship. Behind me, we can now see the first stage of the mold's production. It's being made out of MDF. In terms of its structure, it looks like some kind of pressed paper or cardboard. The first stage is happening now. Milling is underway, making two parts. After that, these two parts will be joined together using epoxy glue. Once it's dry, there will be some rough machining done. Then, this entire part will be fully impregnated with epoxy resin to provide strength. By the way, for clarity, I want to show you what an untreated workpiece looks like. Let me remind you, this is MDF material. As you can see, it has a certain fuzziness in its structure. It hasn't been treated with epoxy resin yet. And this is what a part looks like after it's been through the impregnation and cleaning process, gaining the necessary stiffness and strength characteristics required for the molds used to make various useful parts. In our case, it's a leaf spring. The company here makes blades, propellers, and a whole lot of other things from composite materials. So, friends, we're moving on to the next stage of manufacturing our leaf spring. This is what the finished form block looks like, which we just cut on the milling machine right before your eyes. It's completely ready. The mold has already been made on it, which is exactly where the leaf spring will be baked. A silicone block like this one is now ready, and it will soon be carefully wrapped with composite materials. They've also been cut already, and today we'll have a more in-depth tour here, so that you can get a clearer understanding of how it's all set up, how it works, and the procedure for making the leaf spring. So it'll be interesting, stay tuned.
And is 2150 the whole leaf spring, or is it half?
Half.
So its full length will be 4300? 4300, yes, 4300.
That's half.
Plus, brackets will be attached here, so it'll end up being 4500, from wheel axis to wheel axis.
I understand correctly, it won't be along the airship, but across it?
Across, yes, that's right. Correct.
Across with a curve, right? That's how it goes?
Well, the curve is small. Yes, it's a 3-degree tilt. Initially, we wanted to make it straight, but in the end, we figured that when it's parked, it's going to bend a little bit. Because of that, the wheels would wear down very quickly. So we had to bend it.
Well, I see. So there's at least some parallelism, right?
Yes, right.
And won't there be problems because it's parallel during landing? And it turns out the load won't be from above, as it should be, but just slightly at an angle. That is, if it's coming in for a landing.
No, that won't be a problem. The airship's landing speeds aren't that high.
Well, yeah.
And with a normal landing, if
vertically, as it should be.
You follow the instructions, yes, then the load won't be that great. Actually, there will be more load when it's parked, because it can deviate quite a bit during feathering. We need to somehow dampen that load. Now, if there was only one wheel, it would just keep tipping over all the time, trying to break the wheel, to snap it off.
First, well, we make a master model. First, we grease it, polish it. This is for removing the mold so that the mold comes off the master model easily. Once that's done, we get a mold like this. Look at what a beautiful mold we're getting here. This is already a composite mold. The procedure is the same. We apply wax here, grease it, let it dry for 15 to 20 minutes, then polish it.
And it turns out the mold is also made of composite.
Of course, from fabric. Fabric, yes, everything's the same, yes.
Then how long will the mold last?
Well, if it's well made, maybe for 15 or 20 removals. It all depends on how the mold is made. If it's made very well and you take care of it, why is the process like this? To prevent sticking, because if you didn't grease it well enough, applied the wax, then when you remove it and there's a chip here or there, then you have to start repairing it. If it's constantly being repaired, there will be fewer removals. If you always grease it very well and the removals are clean, then the mold will last a long time. That's it. Naturally, after that, we lay out the part. All our blanks are cut. This is our Prepreg fabric. It's already resin impregnated. There's 50% resin here. Naturally, all these pieces are cut according to the drawing. Fabric direction, plus 45, minus 45, 0, 90. Well, for example, look, here we have it according to the drawing. Yes, here's the drawing. We're looking at the first and second layers. It runs along the entire length. We've laid out the first layer. Completely? Completely. Yes, completely, yes. Here it is, here it is. You see, it's a single piece. Here's the top, here's the bottom. Here are the strips. Short ones, short ones. That means no wrapping, just straight. Naturally, that's why the length varies. Length and the width is different. And the length can be, the fabric, it can end here, one piece of the strip, another can be full length, another ends here, another ends here. Well, either full length or because everything we have comes in fragments. This is a protective film, it's removed. And this fabric, the Prepreg, yes, when you lay it on silicone, you can also heat it with a heat gun, so it gains a bit of stiffness. Because if it's just like this, it'll be all loose. You heat it with a heat gun, it gains its stiffness, and that's it. We wrap this silicone, everything according to the drawing, just as it should be. Then this silicone along with the fabric, which is already applied here, we place it into the mold. Into this one. We put it in here, close it, tighten everything with bolts and take it to the oven. Here's our oven. This is where parts are cured. Parts and Prepreg can be done, whether it's contact layup or infusion. We disassemble the mold. Well, when it's cooled down the next day, that's it. We've disassembled the mold, pulled out this silicone. We pulled out the silicone, checked for any defects on the product to ensure there are none. Sanded it down, and that's it. And we have a finished part ready. This whole technology is used by us and can be applied. Well, the fabric, accordingly, goes into helicopters, airplanes, and airships. That's why why else is Prepreg used? It's much lighter because it's already 50% resin impregnated. If you take infusion, it'll be very heavy. If it's contact layup, it'll be under impregnated. But Prepreg is our most ideal option. It might be more expensive, but it'll be stronger and more reliable, and that's all. This is how we use it everywhere. Well, it's not just in aviation. Fiberglass can be used just about anywhere. It all depends on the molds, the parts, and where it'll be used.
What was the mold taken from?
Oh, well, it's zeroed out here.
Exactly 0?
Yes, exactly 0. Wow, 1 or 2 millimeters, 100th.
Minus 100th?
Oh, a 10th.
Minus a 10th.
Yes, right here as well.
Will it not fit together because of these deviations?
Why are these deviations critical? It'll fit. I just plan to make the bracket plus 0.2 to plus 0.4. Overall, I think it'll slide on. I just wanted the bushings to stick out a bit, you know? So we'd be tightening the bushings, not the leaf spring, because we might over-tighten the spring and it could crack or something. Well, of course, there will be metal steel bushings there. I see. So you'll press the bushings in. Yes.
We could do it the old-fashioned way. Drive a wooden block in.
I suggested that. They said, what block? I said, let's just glue a block inside and drill it there and add more bushings, yeah? To lighten it. They said no. So look, I came and checked. Overall, everything's fine. Well, some dimensions vary, but it's not critical. And here. Yeah, no cracking or anything, but there are a few bubbles. I'm just not sure how critical that is. But can you still mount the bracket? Yes, I can.
All right then.
Well, that's good. I mean, the bubbles, I was mostly worried about the bubbles, the rest.
Ask about the bubbles. Can they fill them with epoxy?
I'll ask now, okay?
All right, I'll talk to you later, okay?
Bye. We'll see. If anything, we'll glue it and it'll be fine. No, the leaf spring turned out well in terms of specs. Overall, it passes. Overall, it passes. Overall, it passes. The main thing is It didn't end up thinner in some places. Basically, slight increases in thickness are generally not considered to be critical. The dimensions are all well maintained. Well, I can't measure the mass here. I don't know. If Oleg gives me a scale, I'll weigh it. But I think we can do that at Vibertex. And again, I wrote the mass as a rough estimate, so it might not match perfectly. So that's not critical either. Its strength and whether we calculated correctly how much it will bend, because it should, with its deflection during a hard landing, absorb part of the load while not deforming. I mean, staying within the limits of elastic deformation, yeah, not cracking or breaking.
So that's what it's needed for. And also so that when we're parked, it would take on part of this load, so that our vehicle doesn't tip over or break off. Our docking unit. So we'll need to test it. Well, it looks very good and impressive. We'll see how it does in the tests. And after the testing, we'll be ordering a new leaf spring. This is just a test sample, it's half a spring. Once it passes the test and we're satisfied, we'll make a spring for Nova 2. For the Nova 2E in this case. But this spring can fit all vehicles in the Nova 2 family. It'll be exactly the same for all of them. So, during the tests, in the tests, we'll first evaluate the spring's compliance with the drawing again. Meaning we will weigh it and check it much more thoroughly and in greater detail for any possible defects, damage, or other issues. Then we will mount it on a specially designed test stand, which is currently being developed, and gradually apply a load, carefully watching how it bends. But this will allow us to plot the relationship between its deflection and the load applied. We'll create graphs and evaluate if it's suitable or not. Maybe we'll need to add layers somewhere. And we'll load it until it completely breaks to see if it can withstand the load we need.